So, welcome to my presentation. I'm going to do a presentation of LabVIEW scripting using Python. But first, I will do an introduction of myself and where I come from. I'm actually from Haar. I'm a consulting engineer at 3D. We are a co-developer partner. We develop and manufacture, innovate, support custom-specific electronics and embedded software through close cooperation with our customers. But we also do a lot of LabVIEW and test systems. We also use test stand, for example. Our company is 50 persons big. We are located in the main headquarters is in Enschede, in the east of Holland. And we have also a department which is especially focused on test systems and LabVIEW in Eindhoven. Well, you can see the numbers. We are we exist since 1994. We are a spin-off of the university originally from University of Twente. But now we are just an independent company. I'm here in the middle. This is me. I'm a little bit more thicker now, but it's me. And we are also an alliance partner of National Instruments since 1988. I was not working at 3D at that moment, but we are already alliance partner for so long. So this is the contents of my presentation. I first will tell you the challenge that we received from our customer, and then the solution and the architecture that we chose for that. And then I will give a demonstration and present the results. And then after the conclusion, and then you can also ask questions. If you really have questions during the presentation, you can just put up your hand, and I will be able to answer the questions. Well, the challenge was to add a Python scripting engine to an existing LabVIEW application. Our customer had already a quite big LabVIEW application with a lot of functionality, but they wanted to use a scripting language to automate certain procedures. Maybe you can think of why don't you do everything in Python, but yeah, there was already a lot of functionality in LabVIEW, and LabVIEW is a beautiful development environment, so we don't want to throw away existing code. But we had some special requirements. The existing functionality must be accessible via Python script. And also the execution of the Python script must be completely controllable via the LabVIEW environment. It needs to be interactive. So you need to be able to start the Python script and to step through the Python script, to pause it, abort it, to place breakpoints, all from LabVIEW, from within LabVIEW. There are some LabVIEW Python solutions, like for example LabPython. It can execute scripts, but it is basically like you run it and then you have to wait until it's done. And it also doesn't facilitate LabVIEW callbacks. You can implement them, but it's not particular. There are no special features for that. That's basically what we added. Instead of LabPython, we invented PythonVIEW. It's those two words together. You have to be creative. And well, the basic operation for PythonVIEW is that from your LabVIEW application, you start a TCP server in which you facilitate all the functions that you want to facilitate from your LabVIEW application. And in that way, you can publish them to your Python script. And then LabVIEW starts the user-defined Python script. just runs it just by running Python from the command prompt and as a parameter your own Python script. And then within the Python script, the user Python script, via a module, and, in this case a LabVIEW lib class .py module, the Python script is able to access the LabVIEW code through the TCP Command Server. There will be a picture after this slide, and then it's maybe more visible what happens. Also, the user script is started using a remote Python debugger, a so-called RPDB server. And via this remote Python debugger, LabVIEW is able to to control the execution of your Python script. Now, this is the same information but then in a picture. So on the left side you have the LabVIEW application, and on the right side your Python application. There are two processes in Windows, and the Python is started by the LabVIEW process. So the first step is that Python starts the user script, and then the user script is directly paused using the remote Python debugger. And then through the PythonVIEW classes, you can start to step through your Python script. And then the Python script can use the LV lib class py module to access LabVIEW functionality. And here, this code can connect to your application code. First I'm going to tell a little bit about the LabVIEW side, and after that I will tell a little bit about the Python side. So this is the LabVIEW class diagram. It consists of a PythonVIEW class, which is the main class that you see when you use this environment as a developer. And then that class will use a so-called Python class and a remote Python debug class. And I will explain them each in the different slides. So the PythonVIEW class, its main purpose is to run a state machine to manage the execution of your Python script. And also it facilitates a simple interface for the developer that uses this this platform. Basically, it publishes the following methods, like to load a script and to step through a script using a next or a step call. With next, you jump over, you execute a line and without going into it, and with a step you can also jump inside a function, inside the subroutine, for example. You can also just run the whole script until the end, or you can stop the execution pause the execution of the script, or stop it. And you can even also just jump to a certain line in your script and continue executing the script from that point. So, and you can also place breakpoints in your script. And they are just simple methods to use. I will give you an illustration later for that. Then the Python class, the main purpose is it's only used by the PythonVIEW class, so as a user you don't see it, it's hidden. And the main purpose is to actually to just launch Python and also and with that also to start your user script, which is all done in the background. And it monitors also the state of your Python execution. So if the script is finished, it will monitor that and those kind of things. And it will also capture the standard output of Python. For example, in case Python crashes, or if you have a syntax error in your Python script, then if you start a script using Python, then Python will directly stop and tell you that there is a certain error on a certain line, and this is captured here, and also in the Python class. And then there's the remote Python Debugger class, and its main purpose is to manage the remote debugger server, so it facilitates all the methods to control your script. So here, this class has methods like to actually step through, to take one step through the code, or to run the code, or etc. Later I will tell more about that. There's one sheet more. Well, then also in the LabVIEW side there was the PythonVIEW class, but there's also a TCP Command Server, and in that you allow Python to send TCP commands to your LabVIEW application and to execute LabVIEw functions. So the main purpose is to capture incoming calls and perform initial parsing of your parameters, and it's to create corresponding command objects. It's also object-oriented. There's a command base, and derived from that there are your specific commands. And it passes the parameters to the command object for further parsing, and then it executes that command and it sends back the result to the Python script. Well, here's a little bit. LabVIEW code is just an example of an TCP command server. Here it waits for incoming connections. Then it waits for data that comes on that connection, and here it will parse the command and the parameters. It will separate them. The command is processed, and a certain the specific class that is connected to that command is created, and then the parameters are also parsed to that class. And then in this step, the parameters are parsed. So it actually calls the parse function of the derived class of the command object. It's a bit technical, but yeah, I'm a nerd. And then it executes that command. So now to go over to the Python side. Well, first, the most important part is the remote Python debugger part. It's actually a wrapper around the standard debug Python debugger, but it allows you to control it through the TCP socket handler. We didn't develop it ourselves. We used Bertrand Janin developed the Python debugger. We used this one. There are more to choose for this one. So this allows for full control of the script execution, and to get also the current position in the script. So that's also being used by the PythonVIEW. It will ask this through the Python debugger. It will ask Python at which point it is in the script, and then LabVIEW can load also that script and display the position in the script live within LabVIEW. Now then you have the LV-lib class, and there you add your interface functions to the LabVIEW command server. And this is an example of an well, here I implemented the interface function for a wait commando. You can wait in Python. Of course you can wait in Python. But here as an example I had a wait command for that LabVIEW waits. So this is the name of the function. And here's the string is built. It's just text wait, and then the parameter, the time that it has to wait is added. And then it's sent to, this is the socket to the LabVIEW TCP command server. And then it waits for a reply, and and then it's also checked if there was an error or not. And this function you can call from your own Python script. Well, then there's your Python script is being executed from LabVIEW, but actually we use a ScriptLoader module, which is a wrapper around your own Python script, and it just keeps your own Python script clean, because there are some certain things that are extra needed, like to connect to the TCP server in LabVIEW and to disconnect it, and also to start the Python debugger to pause the script. And of course you have to import certain these classes, these modules. So and in this way you don't have to do that in your own Python script. So your own Python script stays neat and clean. When PythonVIEW runs your own script, it runs this script, and it will stop at this line, because that's what this line says, to go in debug mode. And then PythonVIEW will automatically step to the next two commands and to jump into this test this function, and that is actually the start of your own script, and there it will stay, stop. This is your own user script. You have to import the alpha lib class module, and in this simple example, just the wait command is executed, and so in this case, actually, the LabVIEW wait command is being executed. So here, the other function is being called, and that other function connects to your LabVIEW Python LabVIEW TCP server, and then LabVIEW will execute this wait command. So there are certain requirements for your own script, and that is that you have to include your alpha lib class, of course, module, and also your method needs to be, your main function needs to be test main. I doubt if that really is necessary, but we implemented it in this way. Now I'm going to demonstrate, to give you a little demonstration of the PythonVIEW. So this is like an application that runs on top of it. But here we just added some buttons that you can load the script and to execute the script. And inside you can see the script itself. So I can show you this in live. So let me try to do that. So here on the top you have to select your script. Panic. Yes, thank you. So on top you have to select your script that you want to load or to run, and then you can just press load. And then here the script is being displayed, and you can just run it. I will just run it for the first time. It's just a simple program that draws lines on a canvas. The customer used this is just a simple example just to make it visible for you, but in real, of course, you can put everything in LabVIEW that you want to be served to your Python script. So let me do it again. And now you can, for example, just step on it. Now it's paused on the line to clean the diagram of the canvas. So, and then you can just step on it. And then it's going to start to draw a line. You can also just right click and to place in a breakpoint, and then to continue. Or you can just run and quickly press pause and to continue. So works all quite neat. Also in the on the bottom, you could, also the call stack is being shown. So if you have a module with a lot of submodules, it will display where you are in which module. So yeah. I will show you the block diagram. Yeah, so as you can see, it's a really simple application of it. It's, if you want, you can connect certain buttons to the PythonView, and then you have to initialize the PythonView, and then you just have to handle the buttons here, and then, for example, you can implement your next button by just calling the next method of the PythonView, and then it will just step. And yeah, this way I implemented all the methods. Just quite simple. For example, if you want to load the script, you can just call the load method and then in the path, and then it will just load the script. But you don't need to use this button. You can also just make just an automatically load the script and run automatically the script, and then to run it in continuous mode or to just run it. Yeah. And here on the bottom, this is the event handler for the buttons, and then here on the bottom is the Python command server that I already showed on the slide before. So I showed this live and also the block diagram. The performance is of course not the most fast way to execute Python code. I just made a little test to see how long certain aspects take. For example, to step through each code using this system, it takes like 600 milliseconds per step. But yeah, how we made it is like you just need to step through each line. But it's also very easy just to run it, just to give over the control of the script to Python, and then to let Python run the script itself. And then, of course, it's again much faster. But if you don't need the speed, which was the case for our customer, then this is just fine. And the nice thing is that you can see live the script execution. So, and well, the time that Python takes to call the LabVIEW commands is about 2 milliseconds per call, roughly. I just measured it using a stopwatch, so it's not super accurate, but it's quite okay. So so using this PythonView, you can load and execute Python scripts using your LabVIEW environment, and you can call through your Python scripts LabVIEW functions, and it's what the customer wanted, so that was quite okay. So yeah, does anybody has questions? Nobody?
Yeah. I noticed that in your block diagram, you first you create a class and then you make a reference of it.
Yeah.
Why do you do that? Because you can just wire it through.
Yeah, it's more like an habit. I like to have everything like to make a reference, and then you can just access it from everywhere you want it, as long as you have the reference. So it's easier to pass the reference to another piece of code, and then it can work on that. And also, I believe that if you do it in that way, LabVIEW doesn't need to make copies of the class itself. It only needs to pass the reference. So it's more efficient. It's also a bit of a habit for me. It's
Makes sense.
actually I didn't do it. I did it there, but here here also there is an. Let me see where it was. Yeah, but it was here. If you go here, I don't make a reference of it. There I didn't make a reference of it. But that was more because I just needed to be quick to make this presentation. Yeah, it's but normally I make a reference. Any other questions? Feel free. You can also ask questions later if you think at home like, wow, now I get it. Then you can always reach me. I have a business card, so you can just get them. So yeah, that was my presentation then. Thank you.